We're going to start this lesson off with the remainder theorem and the factor theorem. So the remainder theorem says, suppose that f is a polynomial function. If f of x is divided by x plus c, then the remainder is f of c. So what does that mean? When I want to find the remainder of these that are divided by x minus 3 and x plus 2, solve what that 0 would be. In this case, my 0 would be x equals 3. So plug that into your function and your remainder is whatever you get. So I'm going to go f of 3 equals and plug in a 3 everywhere you see an x. So we got 3 cubed minus 3 squared minus 5. So f of 3 equals, let's plug this into our calculator. We get negative 14. This is my remainder. So if I was to do synthetic division, this is what we would get our remainder to be. Do the same thing here. Find the remainder. Well, this is x equals negative 2. So now I want to find f of negative 2 of the same thing. Now here the parentheses didn't matter as much. Here they're going to matter. So you need to make sure that you put this one in parentheses. Okay, so I already have this in my calculator. So I'm going to go in here and edit. And before you just punch in negative, you need to insert it. So use your insert. So second insert negative. And then we can change that to a 2. Insert a negative 2. Okay, those are my remainders. So again, from previous lesson, if I was to use synthetic division here, this is what we would get. Well, actually, that is the problem. Huh? What do you know? Okay, this is cool. Sometimes I even amaze myself, guys. Right here, we did x cubed minus 4x squared minus 5 divided by x minus 3. When I used synthetic division, that's exactly what I got my remainder to be. So if it's wanting just the remainder, what this is letting it, it's a shorthand to not let us have to divide either by synthetic or long division. I know that if I just plug in whatever that 0 would be, that it's going to end up giving me my remainder. So an important and useful consequence of the remainder theorem is then the factor theorem. And so the factor theorem, what this is saying is it's got to work both ways. But if you do f of c and you get 0, then that means that x minus c, whatever the c is in factored form, is a factor, or vice versa. If x minus c is a factor, then you should get f of c is 0. So use the factor theorem to determine whether the function is a factor of these right here. So I'm looking for 0. If I get 0, then yes, it's a factor. If I don't get 0, then no, it is not a factor. So here we'll get x equals 1 to be my potential 0. So plug that in. I have f of 1. I'm going to replace all of these x's with a 1. Okay. So 2, 1 cubed. Ooh, and what do you know? We get 0. Okay. So this tells me this means that x minus 1 is a factor. So now here, x plus 2 means that we are looking to see if it has a 0 at -2. And so now we need to do f of -2. And so now I'm going to replace everything with a -2. I'm going to go up here and edit and change these -1s to -2s. And I'm going to do that by inserting a negative. Okay. Make sure I put that all in right. And we get -27. So I don't care what this number is, if it's anything other than 0, if you kind of come up here, this means this is what my remainder is. Because it's got a remainder, that means it does not divide in evenly, so it is not a factor. This means x plus 2 is not a factor. So likewise, these are not factors of this polynomial either.